Hi, everybody. This is Mr. Schmidt, and I'm here to show you some basics of learning and understanding how to use slope. Now, slope is something that we work with a lot every day. If you think about any time that you've maybe gone skiing or rode a bike downhill or anything like that, you have worked with slope. A lot of times people will call it steepness or something like that, but there are many, many examples of using slope. For example, we think of things like ski slopes or the roof of a house or how hard a hiking trail is. You can also use it to calculate future profits, things that increase or decrease over time, or maybe you're developing ramps for a good skate park. But this skill is something that you do a lot in real life, but we're going to take that real life application and we're going to put it in a math classroom to make sure you are ready to understand slope as you get into the real world. So I'm going to take off my webcam here and make sure that we all have our thinking caps on and we are ready to learn. Here we go. So there are four major types of slope. You are going to work with positive and negative slope far more often than you're going to work with the other two examples. Now, we always are going to read a graph from the left to the right, the same way that you read a sentence in a book. You start from the left side and you work to the right side. So as we start from the left side of the graph and we move to the right, if we are increasing, we call that a positive slope, okay? If we think of positive slope, we could think of going uphill, maybe something like going up a mountain or trying to climb Everest, something like that. Negative slope is very similar, except the opposite, where we're going left to right, but we are decreasing, so we call that negative slope. Some examples could be riding a bike downhill. That guy looks like he's having a very fun time on that probably not very sturdy toy that he's using to go downhill. Now, there are two other types of slope that are also very important, but we don't see them quite as much in a math class, but we see them a lot in the real world. The first one is called zero slope. And if you notice from our graph, it means that we are flat, moving left to right. We are not increasing, or our slope is zero. Lots of real world applications of this. The one I thought of is like something like a bridge. You want to make sure that is flat for the most part, okay, to make sure the cars are able to consistently get across it. The opposite of a zero slope is undefined or straight up and down, something that is so steep that you cannot calculate it mathematically. So that would be like a wall or a complete free fall from a path. Okay, that would be undefined slope. Four types: positive, negative, zero, and undefined. This little picture here helps me remember what they are. Once again, moving left to right. The beginning, when we're going uphill, okay, positive slope. As soon as we get to the top of the hill and it flattens off, zero slope. Then we start to decrease again, going down, would be negative slope. And then finally we hit the edge of the cliff and we fall off. I'm guessing he's doing this on purpose for the sake of this picture. And that would be a undefined slope, something so steep you'll fall off. Okay. This picture is what I use to remember and explain to my students the difference between the four types. Now, not only do we have to figure out what type of slope we're working with, we also need to calculate it as a number. And that's where we're going to do it a lot in math class. So how do we calculate slope? And in this case, slope is a number. Now, people almost always will write slope as the variable m. Question might be why? Why did we pick the letter M? And I honestly don't know the answer to that one, but I'm sure if you asked your math teacher, they'd be able to figure that one out for you. But slope is usually the letter M, used most often in the equation y equals mx plus b, where m is the slope, and that's probably going to be one of our future topics. So, how do we calculate slope? Well, the way that I remember is that what you're doing is you're doing the vertical change and vertical means up or down, and you're dividing it by the horizontal change. Okay, now vertical change divided by horizontal change is correct, but it's not very catchy. It doesn't roll off the tongue very well. So I like the term rise over run. Okay, I say this hundreds of times in my math classes, rise over run, rise over run. And the reason why we're going to do rise over run is because we want to know steepness. So as the slope gets higher, you want the line to be steeper, which means we need the rise on top and the run on bottom. Now, all you actually do when you're using a graph like this on the left side is you pick 2 points, which I picked for you. I picked this point here, 0, 4, and I picked this point here, 4, 5. And I want to know from one point to the next point, how much do I rise from here to here? And then how much do I run from there to there? Okay? Now, when we're working with whole numbers, it's a little bit easier than when we're working with decimals or fractions. So we're a little bit lucky in this problem. But we notice from here to here is an increase of 1. So in this case, our rise is equal to 1 from one point to the next. Now, when we're looking at from here to here, we're counting how far over we're going, or how much did we run, which would be 1, 2, 3, 4, which means our run is equal to 4, which means our slope is equal to 1/4. And this is a positive 1/4 because, like we looked in the other pictures, we are going from the left to the right and we are increasing, making this a positive slope, or a positive 1/4 slope. Okay? Now, a lot of times when we're working with slope, it's not given to us as a full graph. It's given to us as a table. Now, at this point, I'm hoping that you know that even if we put points on a table, you still can be creating a line. This is still a line, okay? So when I'm trying to calculate slope, that means that I can pick any 2 points off that line, any points. Now, I'm going to pick these 2 points here, 0, -8, and 2, -12. I could pick any 2 points, but those are the ones that I picked. And I want to know from one point to the next, how much do I rise and how much do I run? So I'm going to go from this point to this point. I want to know how much did I increase from -8 to -12. Now, that's a bit of a trick question because I'm not increasing, I'm decreasing, which makes it -4 for my rise. Then I go from this point to this point, which is an increase of 2 for my run. Well, I hope that we know that -4 divided by +2 is equal to -2 over 1, or -2, which means that our slope is either -2 or -2 over 1. And that means that if we graphed this line, we would be decreasing from the left to the right with a slope of -2. Okay? So that's a really basic overview of what slope is. My hope here is that this is a starting point for you, that we're not mastering the skill, but we have a starting point to try to improve. For practice, I want you to try this problem on your own. Okay, so for the last problem, I want to calculate the slope using rise over run. Now, I need to pick any 2 points off this line. I'm going to pick this one, and I'm going to pick that one. But it doesn't matter what 2 I pick. I could pick any. And I'm going to calculate the rise from here to here. So from here to here, I am increasing by 2. And from here to here, I am increasing by 4, which means my rise is 2 and my run is 4, which is equal to the fraction 1/2, which means for this problem, my slope is equal to a positive 1/2. I hope that was a good starting point for you on slope. Obviously, this is a skill we work on for a long time, and there's lots of improvements to make. As always, if you have any questions, please let me know.